Welcome back to the deep dive. I want to start today by throwing a number at you that, frankly, kind of broke my brain when I first read it.
Okay.
In the world of particle physics, when they're hunting for something massive like, the Higgs boson,
The God particle.
right, the God particle, they have this gold standard for saying, okay, this is real. It's called 5 sigma.
Which is an incredibly high bar. It means there's, what, a 1 in 3.5 million chance that what you're seeing is just a fluke?
Exactly. A 1 in 3.5 million chance. If you hit 5 sigma, you pop the champagne.
For sure.
So, keeping that number in your head, what are we supposed to make of an astronomical anomaly that hits 22 sigma?
That is the question of the day.
Because 22 sigma isn't just statistically significant, it's a probability of chance being roughly 1 in 10 to the power of 107.
Which is just a nonsense number. It's
Yeah.
a 1 followed by 107 zeros.
Right. It's effectively impossible that this pattern is a coincidence. If you flipped a coin and it landed on heads that many times in a row, you wouldn't assume you were lucky. You'd assume the coin was rigged.
And yet, despite those overwhelming odds, the scientific community is currently in a brawl over whether this anomaly even exists.
Today, we are digging into the 22 sigma anomaly. The mystery involves these transient, strange flashes of light captured on photographic plates from the 1950s that appear and vanish.
Mm-hmm.
But the twist in this deep dive isn't just about aliens or, glitches. It's about a new report by Matt Ford from The Good Trouble Show that uses artificial intelligence in a way I've never seen before.
It really is a unique approach. I mean, usually when we talk about AI in science, it's crunching massive data sets or folding proteins.
Right,
Ford used it for something much more human,
right.
to basically referee a logic dispute between two scientists.
He used 3 different AI systems, Claude, ChatGPT, and Grok, to cross-examine a debunking of this anomaly.
And the results?
Well, let's just say the debunking might need its own debunking.
It's a fascinating case study in how science actually works, or, sometimes how it fails to work.
So our mission today is to figure out, did the AI referee make the right call? Is this 22 sigma mystery still unsolved, or was it all just dust on a lens?
Let's get into it.
First, we need to set the stage with the players in this drama. In one corner, making the initial claim, we have Dr. Beatrice Villarreal, and she's not like some fringe theorist on a message board.
Far from it. She is an assistant professor at Nordita in Stockholm. She leads the VASCO project, which stands for Vanishing and Appearing Sources. She's a L'Oreal UNESCO Rising Talents Prize winner.
So she's legit.
Very. Her whole career is dedicated to looking at these old photos in the night sky to find things that just shouldn't be there.
And in the other corner, the critic, Dr. Wesley Waters.
He's an associate professor at Wellesley College, an expert in planetary science. And interestingly, he's also a member of the Galileo Project, so he has a professional interest in UAPs.
Okay, so Villarreal publishes a paper analyzing these transients. These are dots of light on old photographic plates from the 1950s. Now, usually you see a dot that shouldn't be there on a plate from 1952. You just assume it's a defect.
Right. Dust, a scratch, maybe a radioactive particle in the glass itself. That's the default assumption, and it's usually correct.
But Villarreal did something clever. She didn't just count the dots. She looked at where they appeared relative to Earth's shadow. And this is the key part. If I'm looking at a satellite today, I see it because it's reflecting sunlight.
Correct. It's high enough that even when it's dark on the ground, the sun is still hitting the satellite way up there.
But if that satellite passes into Earth's shadow, that big cone of darkness behind our planet, it goes dark. It vanishes.
Precisely. So here's the logic. If these dots on the 1950s plates are just random scratches or dust, they shouldn't care about Earth's shadow.
A scratch doesn't know geometry.
Exactly. It doesn't know where the sun is. It should be a purely random distribution all over the sky.
But that's not what she found.
No. She found a massive deficit, a huge drop-off of these transients inside Earth's shadow. They appear everywhere else, but they statistically avoid the dark zone.
Which implies they need sunlight to be seen.
Which implies they are physical objects.
In orbit in the 1950s.
Before Sputnik.
That is the 22 sigma result. The correlation is so strong that the odds of it being random are basically non-existent.
It's a staggering claim. I mean, if it's true, it suggests there's a whole population of reflective objects orbiting Earth before humanity launched anything.
Enter Dr. Waters. He releases a critique saying, hold on, I've analyzed this and it's nonsense. These are just plate defects. I've debunked it. And usually that's where the story ends, right? The debunker wins, everyone sighs in relief that the status quo is safe, and we all move on.
But Matt Ford didn't move on. And he admits he's a non-expert. He's looking at these two super dense papers and realizing he can't personally judge the advanced math.
So he built an AI jury. This is the part of the report that really grabbed me. He didn't just, paste the text into ChatGPT and ask who is right.
No, the methodology was surprisingly rigorous. He took Villarreal's paper, Waters' critique, and a third, unpublished critique, and fed them into 3 separate high-level systems: Claude, ChatGPT-4, and Grok 2.
And he used this iterative process. He kind of made them talk to each other.
He basically forced the AIs to debate. He'd take the analysis from Claude, feed it to ChatGPT, and ask, critique this. Then he'd take those points and feed them to Grok. He just kept going back and forth until all 3 systems converged on a consensus.
And the verdict wasn't vague. It wasn't, oh, both sides have good points.
Not at all.
Yeah.
It was unanimous. The AI consensus was that Dr. Waters' critique suffers from what the report calls fundamental fatal methodological problems.
The AIs are saying that Waters didn't actually test Villarreal's central finding. He tested something else entirely. The report breaks this down into a hierarchy of failures, which sounds like a heavy metal album.
It does.
But it's actually a brutal takedown of the statistics. Let's walk through them, because when you see the specifics, it's honestly a bit shocking. So, failure number 1, missing clocks.
This is the big one. If you take nothing else away from this deep dive, understand this. You cannot test a shadow hypothesis without time.
Because the shadow moves.
Constantly. The Earth is spinning. It's orbiting the sun. That cone of darkness is sweeping across the stars. So to know if a dot on a plate was in the shadow, you need 2 things: its position and when the photo was taken.
And Waters didn't use timestamps.
He used a data set called Set R with about 5,400 features, but he didn't provide or use the observation timestamps for them.
Wait, hold on. If he doesn't have the time, how does he know where the shadow was?
He doesn't. You simply cannot calculate it.
So how did he claim to debunk the correlation if he couldn't even map the shadow?
That's the mystery. The AI comparison here was just brutal. It said, trying to do this without timestamps is like trying to figure out if someone dodged a car.
Okay.
When you have a photo of where they stood and a map of the road, but you don't know when they were there or when the car drove by.
You can't say he dodged the car. If the car passed by 3 hours later, it's meaningless.
Precisely. Without temporal data, the hypothesis is literally impossible to test. The AI verdict was that this renders the entire debunking mathematically void on that point.
That seems incredibly basic. It's hard to believe a scientist would miss that. But okay, let's move to failure number 2. The report calls it the power outage. This is about sample size.
This is a bit more nuanced, but it's so critical for data science. Villarreal's original analysis used a huge data set. She looked at roughly 107,000 features.
A huge net.
A huge net to catch a signal. Waters, on the other hand, analyzed a subset of about 5,400.
So like 5% of the data.
Right. Now, in statistics, we talk about power. If you're looking for a subtle effect, you need a lot of data to separate the signal from the static. The AI analysis showed that with a sample size of only 5,000, Waters' statistical power was so low that even if the 22 sigma signal was staring him in the face, he likely wouldn't be able to tell it apart from chance.
The report said he could only detect a signal of, 1.7 sigma with that sample?
Which in this field is statistically meaningless. It's just noise.
So he took a data set capable of finding a needle in a haystack, threw away 95% of the hay, and then announced, I don't see any needles.
That's pretty much the gist of it. You can't refute a finding based on 100,000 data points by analyzing a tiny sliver of it. It's like looking at a forest versus looking at a single potted plant.
I see no tigers in this potted plant, therefore there are no tigers in the forest.
Exactly. It's a failure of scale.
Okay, failure number 3. This one actually made me laugh out loud because the logic is so twisted. The circular control group.
Oh, the tautology. This is a logical fallacy the AIs jumped on immediately. In any experiment, you need a control group, right? A standard of what normal looks like.
Sure, a baseline.
Waters created a control group called Set M to define what real astronomical objects like asteroids or variable stars should look like.
Okay, sounds standard so far.
But look at how he defined it. He filtered Set M to only include objects that appeared in both the red and the blue plates.
And those plates are taken about an hour apart.
Yes. So, by definition, his control group only contains objects that persist, that stay visible for at least an hour.
But Villarreal is looking for transients.
Things that appear and vanish in minutes or seconds.
You see the problem.
I do.
Waters defined real objects as things that last a long time. Then he looked at Villarreal's transients and said, well, these don't last a long time, therefore they aren't real objects.
He defined the phenomenon out of existence before he even started the test.
The source uses a bird analogy here that I think makes it crystal clear.
Go on.
Imagine you want to prove eagles exist, but I define a valid bird as an animal that never flies. Then I point to an eagle soaring in the sky and say, that can't be a bird, it's flying. And my definition of a bird says they don't fly.
It's circular logic. It's a textbook tautology. The AI consensus was that the control data set inherently excludes the very thing being investigated. You can't use persistence as a test for something defined by its lack of persistence.
It just feels like we're building a pretty damning case here. But there's one more failure, the geographic fallacy.
This one is tricky because it appeals to our common sense. Waters pointed out that these transients tend to cluster near the edges of the photographic plates.
Which makes you think defects, right? Maybe the lens is blurry at the edge, or the plate holder scratched the film.
It's a reasonable suspicion. But the AI points out that this is a spatial argument, and we're testing a solar hypothesis.
Okay, break that down for us.
Plate defects, scratches, dust, whatever, are physical things stuck to the glass. They exist in the reference frame of the telescope. They don't know where the Earth is, they don't know where the sun is, and they certainly don't know where Earth's shadow is projecting out into space.
Right, a scratch is just a scratch. It doesn't check the time of day.
So even if 100% of these candidates were located at the edge of the plate, that does not explain why they would statistically disappear when the shadow passes over that edge.
The location on the plate is irrelevant to the shadow correlation.
Exactly. It's a red herring. It might explain some of the noise, but it cannot explain the signal. The shadow test is independent of the plate position.
So let's recap. No timestamps, a sample size that's way too small, circular logic in the control group, and arguments about plate edges that don't even address the core question. It's not looking good for the debunking.
It's not. But it actually gets worse.
How?
Because according to the AI analysis, some of the evidence Waters presented to disprove the transients actually supports the idea that they are real optical flashes.
This is the backfire effect. Let's talk about FWHM full width at half maximum.
In plain English, how blurry the dot is.
Okay.
Waters noted that these transients were sharper or narrower than the stars on the same plate. And he argued, well, since they don't look exactly like the stars, they must be fake.
But the AI says, not so fast.
Yeah. Think about how these photos were taken. The shutter is open for 50 minutes. The telescope is tracking, but the atmosphere is shimmering.
Yeah.
All of that causes the star's light to spread out and blur a little bit on the film.
Like taking a long exposure of a highway at night. The cars become streaks.
Exactly. But what if you have a sudden flash? A glint from a spinning satellite that hits the lens for just a fraction of a second.
It wouldn't have time to blur. It's like a camera flash.
Correct. A sub-second flash bypasses all that atmospheric turbulence and the little tracking errors. It should appear sharper and more point-like than the stars.
So the fact that they are sharper is actually consistent with them being real brief flashes.
It matches the physics of a transient reflection perfectly. Waters cited it as evidence of a defect, but the AI flagged it as evidence for the orbiting mirror hypothesis.
That is wild. He handed them evidence for their own case and called it a debunking. And then there's the nuclear correlation. This one is just bizarre.
Right. Waters found a statistically significant correlation, about 7%, between the dates these transients appeared and the dates of atomic bomb tests.
Actual nuclear tests.
Yes. Now, if your data correlates with nuclear tests, that's a signal you need to investigate. Maybe it's radiation hitting the film, maybe atmospheric dust. Who knows? But Waters just dismissed it. He claimed it was probably just a seasonal effect. Basically, that the astronomers and the nuclear testers just happened to prefer the same kind of clear weather.
Did he prove that? Did he pull the weather reports or anything?
No. He just asserted it as a likely explanation and moved on.
And the AI didn't like that.
The phrase motivated reasoning came up. You can't just dismiss a statistically significant correlation with a guess that you haven't tested. That's not skepticism. That's explaining away data you don't like.
It's incredible to see it all laid out like this. It really changes how I view the role of AI here. It's not generating ideas, it's acting as a logic filter. It's stripping away the academic authority and asking, does this argument actually follow from the premises?
And that's crucial because scientific papers can be so dense and intimidating. It's easy to hide a weak argument behind complex vocabulary. The AI just peers through all that to ask the simple questions. Where are the timestamps? Is this logic circular?
So where does this leave us? The source makes a comparison to a historical figure, Donald Menzel. Who was he?
Menzel was a Harvard astronomer during the Cold War. He was famous for being the anti-UFO guy. He would debunk reports with extreme confidence, usually citing things like temperature inversions or ice crystals.
Which sounds very scientific.
It does. But later, researchers who looked back at his work found that he often didn't actually check the data to see if those conditions were present. He just used his authority to dismiss claims without doing the work to prove his alternative.
Right.
It was performative skepticism.
And the suggestion is that Waters might be falling into a similar trap.
The suggestion isn't that he's acting in bad faith, but that the critique allows for dismissal without actually engaging the core data. It's what the source calls the marble analogy.
Oh, I like this one. It really clicked for me.
Imagine a bag with 100,000 marbles. 90,000 are just gray gravel noise, dust, garbage. But 10,000 of them are bright red marbles that follow a specific pattern.
Okay, so you have a mix of signal and noise.
Waters essentially looked at the bag and said, look at all this gravel. This is clearly just a bag of gravel, therefore the red marbles aren't real.
But the whole point of statistical analysis is to find the pattern inside the noise.
Exactly. Saying there is noise in the data is not a rebuttal. The 22 sigma calculation already accounts for the noise. It says, despite the gravel, this pattern of red marbles is impossible to ignore.
So the debunking is, well, debunked. Does that mean the transients are definitely alien satellites?
No. And we have to be very careful here. The AI did not confirm that Villarreal's hypothesis is true. It simply confirmed that the attempt to disprove it failed.
The 22 sigma anomaly is still standing. It hasn't been knocked down.
It's an open case. The source outlines exactly what a valid critique would need to do. If you really want to debunk this, you can't take shortcuts. You need to use the full data set, all 107,000 points. You need the timestamps. You need to calculate the shadow positions, and you need to run the same statistical test.
If you do all that, do the actual work, and the signal disappears, then it's over.
Correct. Then we can say it was an artifact. But if you do all that and the signal's still there, then the scientific community has a very uncomfortable reality to face.
It really highlights why this matters to everyone, not just astrophysicists. We rely on experts. But even debunkings need to be fact-checked.
Absolutely. Skepticism is the lifeblood of science. But skepticism that substitutes dismissal for replication doesn't advance science. It stalls it.
It makes you wonder, if a 22 sigma anomaly, something that is effectively impossible by chance, can be waved away by the scientific community based on a flawed critique just because it doesn't fit the standard model, what else are we ignoring?
That is the big question. History is full of things that were impossible until they weren't. Stones falling from the sky meteorites were considered peasant superstition by the French Academy of Science. They refused to even look at the rocks because they knew rocks couldn't fall from the sky.
Maybe these transients are just glitches. Or maybe, just maybe, there's something waiting in the dark, in the shadow of the Earth, that we've been looking at for 70 years and refusing to see.
There's only one way to find out. Someone needs to run the test properly.
Dr. Waters, Dr. Villarreal, the ball is in your court. And to our listeners, thanks for joining us on this deep dive. Keep questioning, keep learning, and we'll see you next time.